Hi guys, welcome back to another video. In this video series, we're going through the programming of the Asuro robot using C programming language. So we're still on your first program in the Asuro manual, which is on page 54. And the original code was the code that turned the status LED red. Since then, we've used some for loops, some if statements to get the status LED to flash green and red backwards and forwards on a loop. In the last video, we used this for loop, these two for loops, inside this while loop to get the LED to flash 1,000 times green and 1,000 times red and do that backwards and forwards. So we noticed in the last video that there were many limitations to using a for loop. One being in terms of getting the Asuro to count to 1,000, it counts very quickly. So in this video, what we're going to be doing is we're going to be using the sleep function, which the microprocessor that the Asuro uses has built into it, which allows the processor to sleep for a certain period of time. This sleep function is explained on page 67 of the Asuro manual. You'll see it here, 9.25. Void sleep unsigned character. This function will command the processor to wait some time. The waiting period may be defined by a parameter, i.e. in these brackets, containing a number of maximal 255 and counting cycles from a 72 kHz timer. So it explains that for 3 milliseconds, then 216. So it says in order to get the processor to sleep for 3 milliseconds, then you would put 216 in the parameter. So you put the function sleep 216 will force the processor to wait for 3 milliseconds. So you put in your code sleep brackets 216. So this is where the Asuro manual really comes in handy. So what we'll do is we'll write our code now with using the sleep function in mind as well. What we'll do is we'll carry on using this code that we built in the last video, and we'll just improve on it. So let's start with our pseudo code first. We're still going to keep the same pseudo code. This time, what we're going to do is we're going to add here sleep 3 milliseconds. Sleep 3 milliseconds. And again here sleep 3 milliseconds. Now, if we get it to sleep for 3 milliseconds and we do it 1,000 times, that's going to be 3 seconds each. So that's going to be 30 seconds each. Let's change it to 100. That'll be 0.3 seconds, because 3 milliseconds times 100 would be 0.3 seconds, right? So we keep everything the same. What we do is we just put sleep 216, and same again here, sleep 216. So this will get the processor for 3 milliseconds. Put that here, right? And then what we're going to do is we're going to get this for loop. We said that would get it to 100 times. So we change I is less than 100. And so what that means is that 3 milliseconds of sleeping times 100 equals 0.3 seconds. Let's make that equals, right? Cool. So what should happen here is that it will start this for loop, right? You go into the while loop, start the for loop, turn the LED green, then wait for 3 milliseconds. Then I becomes 1, do it again, wait for 3 milliseconds. So the LED was, once it's turned green, it will obviously stay green for that 3 millisecond period. So the one thing that I need to mention is that depending on which library you're using, this sleep function as is like this may not work. And what you could do is you might need to use the newer function, which depends. If you downloaded the one from Jurgens Homepage, which is linked in the description, then you might need to use this msleep, which is basically a newer version of sleeping. And what you do is you do it like this, and that would sleep the processor for 500 milliseconds, right? And then so if you wanted to sleep for 1,000 milliseconds, i.e. 1 second, do that. So that would be for the new function. This wouldn't work if you have the older library though, so test both and see which one you've got working. For my library, the sleep function works fine for me. Cool, so now let's take a look at our results for our program. Here's a video of what happens when we set I to 10, like so. So I will count to 10, It'll sleep the microprocessor for 3 milliseconds 10 times, which should equate to it flashing 0.03 seconds each one. Now here's the video of the Asuro flashing when we set I to a maximum of 20. And here's a video of the Asuro flashing when we set I to a maximum of 50. And here's a video of flashing when we set I to a maximum of 100. So as you can see now, with this method, we have pretty much complete control over the blinking of the LED. And if we want to, we can set I to 1000 and it will literally then blink every 3 seconds. Set it to 10,000, it will blink every 30 seconds, etc, etc. And it gives us a lot more control over the microprocessor. Another thing that we can do as well, which I would suggest that you experiment with, is we can actually duplicate this and get it to sleep instead of every loop iteration. Instead of getting it to sleep once for 3 milliseconds. I might keep saying microseconds, but I mean milliseconds. Instead of getting it to sleep for 3 milliseconds, we get it to sleep for 6, or we can do 9, or 12, etc, etc. So you can actually do this, and we could even put it in a loop again and do a second loop. So it gives us complete control now. And using this sleep function, you're going to use it a lot. We'll use this to drive the motors using the sleep function, etc, etc, etc. So I highly recommend playing around with this. Try to use different values. The maximum value that we can put in there is 255, so you could work out how long that would be. I stick to the conventional 216. And yeah, one reminder that I'll give as well, all of the code that I'm writing is available on my GitHub. Link is in the description for that. And thanks for watching. I'll see you in the next one. Peace.